Oh,
Okay, so on your notes,
you hear record?
we should be at the bottom of the first page. And electrons, I think, were the last thing we filled in. Okay? So electrons, remember, we had that in the chart up there. We had protons, neutrons, electrons. Electrons are the smallest. They're all negatively charged. They're located outside the nucleus. Right? And does anybody remember how small they are? What their size was?
Little bit.
Did you write it down?
1 over 1,000 amperes.
Right. Over 1,806 of an AMU, so they're very, very small compared to the others, okay? Alright, so now electrons are found outside the nucleus in what we call the electron cloud, and they travel in things called orbitals, okay? And each orbital is a three-dimensional region, or 3D, I like to shorten it, 3D region around the nucleus. And that's the probable location of an electron. Anybody know why it says the probable?
Because they move so fast, you can't tell them anything.
That is it. That's it. Exactly. There's not like one point you can say, okay, the electron's right there. Because it's now gone. You know what I mean? They're moving. They're moving all the time. Okay? And so, here's your electron cloud, like this blue shaded area. And remember those things called energy levels? Did you learn that last year? Okay. So energy levels, the first energy level only has one orbital. And I'm going to do this on the next slide. But each orbital can only hold 2 electrons total. Okay? So, did you guys ever have to draw any electrons last year?
Yeah.
Thinking you did. Okay. Awesome. So we're going to do some of those in a second. But when those electrons are, moving from energy level to energy level, they don't really move. But what I'm saying, like starting at the first energy level and then going out to the second, going out to the third energy level, which energy level or which electrons do you think are going to have the, the greatest amount of energy? The ones that are closer or the ones that are farther from the nucleus? Closer, you think, has more energy?
No.
If the farther away has a greater amount of energy. And so the reason that is because, the first energy is close to the nucleus, and you know how that fills up first? You guys learned that last year. We're going to do some of these pictures in a second, but the first energy level, they fill up first. And so they're also not getting as far, they don't have as far to go or to travel, and so they don't have as much energy as the ones that go farther away from the nucleus. Okay? So that was a test question. You guys see that little star there? Oh, it's not there yet. There it is. There's your star. Remember the little stars? Those are test questions.
Wait, I don't see a star.
It's at the end.
Oh,
I see it.
got you.
All right, there you go.
It's not very big.
Yeah.
You know that stars is.
Okay.
You're so smart.
Superstar.
Oh, yeah, I got you. That's a good one.
Okay, so the electrons that are farthest away from the nucleus have the greatest amount of energy, so I know you filled that in. And then we were talking about those energy levels, right? The first energy level is only going to have one orbital, and it can hold 2 electrons. Each orbital holds 2 electrons. Second energy level has 4 orbitals, and it can hold 8 electrons. So I'm going to kind of show you what I mean by this in just a second. Right, is that filled in? Let me switch over so I can draw something out here. Yeah, a little switch. Okay, so let's say that we're going to draw oxygen. Okay, oxygen is atomic number 8. Alright, and it has a mass number of 15.9. Okay? So when we go to draw oxygen, what do I do? First to draw, what's the part that holds the protons and neutrons? Nucleus. Okay. So we're going to have our nucleus. And how many protons will oxygen have?
8.
8. Got that from the atomic number right there. 8 protons. And then how many neutrons for this one? 8 also, you get that by taking the mass number, round it to the nearest whole number, minus the number of protons, gives you 8. Sorry, I don't know where that came from. 8. So 8 neutrons. Okay? Then, how many electrons will it have? 8, and how do you know? They're not always all the same, right? So how do you know? It should be the same as the protons, right? So the first energy level here, okay, that first circle around the nucleus is the energy level. And it has what we call one orbital. And so it's kind of like an orbital kind of goes like that. Can you go with this? And it will only hold 2 electrons. Okay? So that's what I mean by orbital, but I'm going to erase it because you probably haven't seen that before.
No, it kind of looks weird.
Look like Saturn.
It did look like
That's
Saturn Venus.
okay. What you guys probably do is you just do the circle and then you put a dot there, something like that. Or maybe outside, it doesn't matter at this point. Because remember they're in that orbital and they're moving. So not only is that circle that I just switched over a second ago, but then it's also moving all around the nucleus. Okay. Alright, so then what do? I have to go to the next energy level. 6 can only hold 2 electrons in this first energy, right? So it's the second energy level. Okay. And I have 8 total and I've used 2. So how many are left?
6.
Okay. So you go 1, 2, 3, 4, 5, 6, like that. And then you have oxygen. Right? Okay. So, just to kind of remember, the first energy level can hold 2. How many can the second energy level hold? 8. 8. Okay? And then if we were to draw a third one, that would also hold.
And a fourth.
Okay, you're right. We could keep going, but we're not. We're not going.
We're only
How many orbitals?
Oh, there could be a lot.
quadrillion.
Yeah. We're not going to do all that. No, I'm not doing it. Okay, so that's kind of how we're going to draw these. So let me give you one more. Let me randomly pick on one of these. One of these. How do you feel about it? Or at least that one's back. Might be able to do it? Okay, let me pick one. We're going to do boron. Thanks. Got the boron. I got it. All right. That's 10.811, sorry. Okay? So from here, what do I do first? Draw my nucleus.
Protons
Good?
and 6 neutrons.
Good. And how do you get that?
Well, protons are the same as the atomic number.
Good. Protons come from the atomic number.
And take this mass number, subtract the atomic number from it, and you get 6. Yep. No, 5 electrons.
Good. Because it's the same as proton. So first energy level, 2 electrons. And only hold 2, so you have to go to the second energy level. It'll have 3. Good. Good job. Yes, sir.
So confused. Electrons.
And so, technically, like if I were going to draw this, there's my nucleus. This first energy level is going to have 1 orbital, and that orbital is like kind of moving all around this, right?
The orbital is important.
It is.
Okay, that's I got it, but I don't got it. But I got it.
It's kind of one of those abstract things.
So all the electrons are power.
Okay. And then, I'm going to erase this, so I have more right here.
Good.
Then, the second energy level, remember, is going to have 4 orbitals.
That's why we.
So how are you
There's
working?
Now, I only made them small, but technically, remember how I showed you that before? They're going like that. Okay, fine, So there's your 4 orbitals that are in the second energy level, and they're surrounding the whole thing. And those electrons are traveling all the way around it all the time. Okay?
Way faster than that. Possible.
Yes.
That's just like
Yes.
so on the test, how are you gonna want to read them with the orbital level?
The only reason I'm going through this is for our next part, which is on bonding. So you don't necessarily have to draw one by itself, but you need to know how they're going to bond together. Okay? So you need to know how many each electron, how many each energy level will hold of each electron, and then we're going to need to know how they bond together. That's kind of where we're at. Okay. So we're going to go ahead and fill in isotopes on your notes, which is the last thing on the first page, I believe. And then we're going to talk about bonding. So isotopes are atoms of the same element that have a different number of neutrons. So what distinguishes an atom? Like, how do you know each atom from the other? The number of protons. Good. So the atomic number is how we distinguish one atom from the other. So atomic number 1 is what atom?
Hydrogen.
Hydrogen. Good. Atomic number 2 is what element?
Helium.
Helium. Okay. So anything that has 2 protons is automatically, we know that that's helium. Anything that has 8 protons, judging by what we just saw a minute ago, is what element? Oxygen. Okay? So the number of protons is what distinguishes each element from the other. Okay? So that's good to know, because what we have here is we have 2 atoms that are both helium. However, the atom on top has only 1 neutron. You guys see that? So the protons are red, there are 2. Helium is atomic number 2. And it only has 1 neutron. Right? And so the mass number is 3. 3 minus the 2 protons leaves you with 1 neutron. This one on the bottom has a mass number of 4. Okay? It's also helium. So 4 minus the 2 protons, that makes it helium, leaves you with how many neutrons? 2. 4 minus 2 is 2, right? We did, that's all right. So 4 minus the 2 protons leaves you with the 2 neutrons. Okay. Now there are a bunch of other ones. There's carbon 12, carbon 13. I don't know if you see that very well. And carbon 14.
Yes,
You guys heard of this before?
Yes.
Carbon's atomic number is 6. Okay. So atomic number, is that better?
Yes.
Of carbon is 6. That means it has 6 protons. So all 3 of these elements, carbon 12, carbon 13, carbon 14, they all have 6 protons because they're carbon, right? But can you see what their mass numbers might make their neutrons different, right? So 12 minus 6, how many neutrons?
6.
This one has. So that one will have 6 neutrons. What about carbon 13?
7.
Okay, it's going to have 7 neutrons, and carbon 14 is going to have 8 neutrons. Okay, but all of them are carbon.
But they're not.
Well, they are. They're still carbon,
Still carbon.
but they have different versions of carbon. There you go.
This is
Look at that.
well,
Okay. So yeah, 12, 13, and 14, those are the mass numbers. Okay.
is there like a carbon 17?
Probably not.
I don't know. Maybe. But, okay, so we are going to talk more about isotopes, but that'll probably be tomorrow. So I'm going to skip over that, and we're going to do bonding today. Those were radioactive isotopes that we're going to talk about tomorrow.
Are we gonna go camping? What are we gonna bond?
Oh, okay, so compounds. I think we're at the top of page 2. Compounds are going to have 2 or more elements joined in a fixed proportion.
I was looking.
I'm going to name that. 2 or more elements joined in a fixed proportion. So, anytime that we're joining these atoms together, we're usually making a compound. All right? So you guys have all heard of water, I hope, anyway. And so water is H2O. My fixed proportion means in order to make water, how many hydrogens do I always have to have? 2 hydrogen atoms to every, how many oxygen? To 1 oxygen. That's a fixed proportion. 2 hydrogens to 1 oxygen. Okay? The second one, carbon dioxide. How many carbons are there? 1. How many oxygens?
2.
2. Okay? And so 1 carbon to 2 oxygens. So that's our fixed proportion. And so when we're joining those 2 atoms together, that makes a compound. So compounds are formed, we said, by joining them together. Well, they join together by a process called bonding, right? And there's a couple different types of bonding that you probably learned about last year, hopefully. Covalent bonding and ionic bonding. Remember those?
Yep.
Well, I hope so, because we're about to do covalent. All right, so covalent bonds are when these atoms share electrons. Formed when 2 atoms share electrons. Now, does anybody remember why they want to share electrons? Why do they want more electrons?
So they can fill it there also.
Good. Good job. All right. So they can fill up their outside ring. And what is that outside ring called? Raise your hand if you know. Outside ring. The outside energy level. It's got that.
Valence.
Nobody's raising your hand.
We didn't raise hand, Hunter.
Hunter.
Valence.
Valence shell. Okay, your valence. Your valence electrons are your outermost electrons. Right? You guys remember that?
Yeah.
Okay.
Yes.
So oxygen, remember, had 2 in the first, and it had 6 in the second, right? So in its valence shell, it had 6, okay, in its outermost shell. Now, how many did we say that second energy level could hold?
8.
Total. 8. So 6 is not 8, so it's not full. These atoms want to have that valence shell full. They want to be stable, you call it, okay? And if they're not, then those electrons are moving faster and faster and faster, okay? Until they're trying to find something to bond with, let's say. All right, so they want to fill up that outermost shell. And so oxygen needs how many more electrons to become full?
2.
It's 2 more. Very good, okay? So that's why they bond. They want to fill up that valence shell, okay? So oxygen that we just did, we drew a picture of it just a second ago. It has 6 in its outermost. It needs 2. Hydrogen, what do we know about hydrogen?
Has 1.
Has 1 electron, right? And how many can that first energy level hold?
2.
It can hold 2. So it needs 1 more. Well, you kind of see how these 2 are going to go together. Basically, we've got hydrogen with 1 electron out here. And remember how we had oxygen had 6 of them, right? So, sorry, what that Hunter?
Okay, so why would it bond with like helium?
Helium is full. It's got 2 in its outermost. Very good. Okay. So if we look at this, basically you got hydrogen with its 1 electron. The blue are the electrons, the red are the protons. Sorry. And oxygen, remember, had 6 in its outermost shell. So I'm just drawing the valence shell of oxygen. Okay. And what's going to happen is they're going to share electrons. Okay. Now we represent that usually by a single line, and that means that they're sharing 1 pair of electrons. And when that happens, when they share, it kind of pulls them closer together. So if you look at picture 2 right here, you see how there's kind of like this bluer shading, darker part. What happens is when they share electrons, it brings them closer together, and therefore that's their bond. They're sharing those electrons, brings them in together closely, and they share those electrons. So now oxygen, if you look at it up here, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Okay? And so they appear, they feel like they're full, if their outside shell is full. Hydrogen has 1, 2, and it feels full, and this hydrogen 1, 2. Okay, and so it feels full. Alright, so everybody understand what's going on? Because we're going to do so here in a second. All right, so let's draw. But we just did kind of do water, so to restore. Sorry. It usually goes. There it is. All right, so let's actually draw out water. Well, let's do that one. We just did that one, kind of. So let's do this one. Anybody know what this is, CH4?
No.
You know.
I'll just check and see if you know. You might not. It's methane gas.
Oh, yeah, that's not.
I wish I was so fresh.
Yeah.
I like that.
I got.
Methane gas, yeah, it's
Special.
released by us and all sorts of animals. The bacteria break down our food in our digestive tract. They release methane gas. Therefore, we do. If you know what I'm saying.
Yeah.
Follow the intestine.
Not
Okay. All right. So, what we're going to do is CH4 methane gas. Here's our fixed proportion. How many carbons do I need? One. And how many hydrogens do I need? Four. Okay. So, first thing is let's draw out carbon. You know, draw a little periodic table. Carbon is atomic number 6. And its mass number is 12.01. Okay? All right. So if I pick on somebody, she's not here. Penny is though.
Yeah.
All right, Penny. How will I draw carbon? Or do you want to come draw?
Oh, fine.
Okay.
Yeah.
Oh, you want to put a circle?
Sure.
You put there's 6 protons.
There are 6 protons.
And then you want to draw your colors.
Okay.
Don't forget about the
Yeah, that's 6 neutrons.
There's 6 neutrons. Yep. How many electrons will there be? Equal to the number of protons.
6, so it's 2 in that one, and then there's 1 out.
I'm going to make them as each. You make them as dots.
And then you draw the color out.
Okay.
Yeah, and then you draw 4 of these.
4 each.
4 of these.
Okay. That's 6, right? So 6 total. 2 in the first, then that leaves 4 for the second energy level. Now, is carbon full? Are they stable?
No, it needs
No.
more.
How many does it need?
4.
4 more. Okay. So, the carbon's got to do a lot of bonding, right? To get that full. And so that's where each of these hydrogens come in. So, hydrogen. Sage down. Austin, right? How do I draw the hydrogen?
the deal itself.
Yeah.
Okay.
Well, you can tell me or you can draw it. Okay, we'll start with the circle.
Okay, put the circle there.
What's the circle? If I make my hydrogen right here.
And there we go now. You gotta get 1 proton.
Okay.
Sifu.
No.
Neutrons.
Good.
Okay. If you have 1 electron. Just like that.
Just like that. Okay.
Yeah.
Okay, keep doing that.
3 more.
How many do I need?
3 more.
I need 3 more. You're right.
3 more.
That was very circle, but it worked.
One more. Oh. Try to stretch it.
Yeah, there we go.
Okay, so now for the hydrogen, all 4 of these hydrogens, they only have 1. Their energy level holds 2, so they need 1 more. You see how this fits together pretty good?
Yeah.
So what we're going to do is we're going to draw a straight line between each of these electrons. And you guys might have circled them. I don't know. Did you circle them? like this?
No, we don't do that.
Yeah, we do that. I drew the line.
I think it depends on your class. that you had.
Yeah, how do we get that?
All I need is a line, that's all. Sorry, I kind of messed up. Anyway, and so what this shows you is that we have a single covalent bond, which means they're sharing one pair of electrons between each of these, okay? So if you count them, this hydrogen has 1, 2. Is it full?
Yeah.
Yeah,
Yeah.
it's good, right? This hydrogen has 1, 2. Good, right? This hydrogen has 1, 2. And this one 1, 2. So all the hydrogens feel full. Now carbon, you count them, right? This carbon's going to have 1, 2, 3, 4, 5, 6, 7, 8. And it feels full as well. And so this is how they bond together. They bond by their electrons. Okay, and sharing those electrons brings those atoms closer together, which makes them become like basically combined. Oops, not too far. Okay, NH3.
I used to know this one. Probably not that. I've seen it.
That makes sense.
Well, it's news. No.
Alright. Oxygen is atomic number 7, and that's factor 3.000 something, 007. Okay. Alright. So, nitrogen, atomic number 7. Sarah. Alright, you want to tell me how? Okay. Okay. Good. Okay. So there's nitrogen. Everybody go with that?
Yeah.
Okay. And then basically what nitrogen is going to do is it's going to need how many? Does it need 3? If you look, it's missing one here, here, and here, right? So it needs 3 to become full. Is that right? See what I did there? Okay. And so basically these hydrogens, okay, that has 1 electron.
Can we draw it like
Does
that?
anybody see I'm shortening this up a little bit as we go?
Yeah.
Okay, just check it.
It's great.
And so this hydrogen, they all have 1, they need 1 more. And so what we're going to see here is now nitrogen is going to become full because it's got 1, 2, 3, 4, 5, 6, 7, 8. Okay? And now all the hydrogens have 2. Okay? So these are single covalent bonds. Once again, this is a single covalent bond right here between this. They're sharing 1 pair of electrons. I'll show you a double covalent bond. Everybody ready for that?
Hair.
All right. It's going to be a double covalent bond. Now, we can shorten this up a little bit, right? Because the more you do it, I wanted to show you how everything is distributed. Okay, now you might have done maybe something like this. Did you do that last year at all? It was that diagram.
We're supposed to.
Maybe you didn't.
No.
Okay, so what I'm going to do is just kind of show you, just going to put carbon there. I'm not going to do the protons and all that stuff. I'm just going to put carbon in there as my nucleus and know what I'm drawing. First energy level, remember had 2, and carbon was 6, number 6, right? So that means that it's going to have 4 in its outer core. Okay. Everybody doing it like that? Are you okay?
No, I'm good.
Okay. Now, oxygen, remember, had atomic number 8, 2 in the first, 6 in the second. So it needs how many more? 6 in the second.
2.
Needs 2 more. Okay. So oxygen basically had 1, 2, 3, 4, 5, 6. See what I've done? I shortened this up again. Okay. And it needs 2 more. So what's going to happen is oxygen's going to bond with this carbon right there. Is everybody okay? And see how it needed to share 2 of them? because it needed 2, right? 2 more, so it's going to get them from here to here. Then over here, I'm going to throw another oxygen. Okay, that has 6 total valence electrons. It needs 2 more. Well, it's going to share these carbons right here. And now we have carbon dioxide. And so what we have is a double covalent bond right here. It's a double covalent bond because they're sharing 2 pairs of electrons between different atoms. Okay. You see that? And another double covalent bond over there because they're sharing 2 pairs of electrons. You okay? Everybody all right? Okay. Now, let's try to figure out what kind of bond this one's going to be. It's nitrogen gas. Okay. Okay. So if I was going to draw nitrogen.
Can we do that on tests?
Well, yeah, we don't have to do a whole lot of the project atoms.
Can we do the conversion?
Yes. Alright, so nitrogen has a total of 6 electrons. I get 2 in the first, and how many's left for the second? 5, right? Nobody's yelling at me for doing this. Okay. Alright, I've been told that you guys you could just put them wherever.
No.
Remember that they're moving all the time, right? Okay. And so nitrogen, we have another one here. 2 in the first, 5 in the second. Okay. And then what we're going to see is how many does each nitrogen need? 3. It needs 3. It has 5, if you told 8, it needs 3 more. So guess what? Those are going to share. Those are going to share, and those are going to share. And we now have a triple covalent bond because they're sharing 3 pairs of electrons between 2 different atoms.
That's last year, the way that we did it was we flipped it over at one set of electrons,
Like that, probably.
and then we just kind of moved them together and multiplied to have them touch.
What?
It's like after. Or did you draw it bigger all the way around it or something like that?
Yeah.
That's what I did earlier.
We need to do that.
I like to show it this way because guess what? Pretty soon we're going to throw all of that other stuff out as far as all, how the energy levels and drawing all that. We won't have to do that. And pretty soon we're just going to do this. But, oh, yeah. Remember that?
Yeah.
Okay. Or, like, for instance, you remember, I don't know, do you remember methane gas? What's CH4?
Oh, yeah.
That's familiar.
Oh, yes.
Okay. That's structured free. We're going to do all this.
Can't we just do it now?
Well, you can do a little bit of it now. This chapter is understanding, kind of understanding where the electrons go, why they need to bond. Okay, because everybody, you understand they want to be full. That's the main reason that they're bonding with others. And then when they bond, that's how we form these compounds, and that's how we're combining these atoms together, these elements together. And so the basis of biology, you guys, is chemistry. Okay? And so you get, you had a little introduction to chemistry last year with physical science. And so then we kind of need to build on that just a little bit more to understand how all of us are made. Because we're all made of matter, which is made of atoms, right? So atoms make matter. And here we are.
Once we get past all of this stuff, then
It's down there.
Then we're going to finally, what we're doing is we're starting small. Obviously atoms are the smallest, right? And then we're going to build up to molecules, and then organelles and cells, and then, we kind of get bigger and bigger and bigger. Yeah.
We're just gonna snowball.
We're just going to what?
Snowball.
Snowball, yeah. We're gonna start small and work our way up.
Oh, that's
Okay. So, does everybody feel okay with covalent bonds?
Yes.
No?
Yes.
Because we're gonna move on to ionic bonds, if you're okay. Alright, so I think ion goes in your first slide. Or not first. Did everybody put some examples down for covalent bond? We just did a whole bunch of examples. Well, it says the X, and that means examples. So like H2O is a good example, or carbon dioxide, CO2, or CH4. Those are all examples we did. Oh, and N2 we did. Those are all examples. Okay, so an ion, what's it is an atom or molecule that has an electric charge. So at this point, up until now, we said that our atoms had the exact same number of protons and electrons, right? The same number of positives and the same number of negatives, right? Everybody good with that? Well, what's going to happen with an ionic bond is all of a sudden we're not going to have the same number anymore because one of those atoms is going to give away an electron. And therefore, no longer will it have the same amount. Okay, so an ionic bond is formed when one atom gives up an electron to another, I should say, sorry.
It's all coming back.
Good, it's coming back. Glad to hear that. Is everybody okay with this screen for a minute? I'm going to go back to the smart word screen. Almost, sorry. Okay, so this whole time we've been drawing these atoms. We said, okay, oxygen has 8 protons. And we said, okay, it has 8 electrons. Well, that's still going to hold true when we first draw these out. But then, remember that they want to fill that valence shell. So they're going to do, these atoms are going to do whatever is the easiest or the best way for them to get more. To get full, however you want to look at that. Let me add a new one here. Okay, so let's take, for instance, let's do potassium. It's a big one. Potassium is atomic number 19 and 39.098. Okay, so if I were to draw potassium, we're got our nucleus, right? We're going to have our protons in there. I'm just going to put potassium, okay? First energy level, how many electrons will it have? 2. Second energy level?
8.
Okay. Then so that's 10 total, and how many do I get to?
19.
19, okay. So that's 10.
8.
You're going to go here.
8.
8.
18.
Okay, so I'm at 18.
And another one.
I need one more, right?
4.
Okay, so potassium, here we are. We have 1 in our outermost energy level. Is it going to be easier for potassium to get 7 or to just give away 1?
Give away to 1.
So this is where potassium said, hey, I'm going to take the easiest route and I'm going to try to get that valence shell full. And if I give away 1 electron and it goes over here somewhere else, then this outermost energy level disappears and they're full, right? The potassium will be full.
Yep.
Now you told me a minute ago, we said potassium has 19 protons, and a second ago it had 19 electrons, right? But we just gave one of those away. So how many does it have now? If you did a positive 19 and a negative 18, what are you left with?
1.
You're left with 1 positive. So now potassium becomes a charged particle. It becomes an ion because no longer are the protons and the electrons even. Okay? So now we have more positives than negatives and it becomes charged. Everybody go with that? Alright, so I'm going to pick up with salt tomorrow. We'll do that example.